Okay, so today we are going over lesson 6.3, which is trig functions and real numbers. So we will look at something today where we're using the unit circle. So yesterday we went through and used the special right triangles and what we knew about degrees and radians to fill in the unit circle with each of the degree measures, each of the radian measures, and then each of the points on the circle for those angles. And so you should have your notes out from yesterday because we are going to be using the unit circle to answer the questions today. So what I've done is I've just kind of pasted a printed unit circle here. So remember that the inside values are the degrees, and then the values inside the circle right next to the circle, those are the radians for the most part. There's a couple degrees in there too. And then the outer points are the ordered pairs that correspond to each of those points on the circle. And so we use the special right triangles that we cut out yesterday to build this. And so we will be using the unit circle from now on to identify sine, cosine, and tangent values of functions. And so we're going to look at the relationship of the triangles that we used yesterday in the unit circle to identify sine, cosine, and tangent values. So one thing to remember is that we have already reviewed that the mnemonic device SOHCAHTOA tells us the trig ratios for each of the three basic trig functions, sine, cosine, and tangent. One thing that we want to think about, and I'm going to draw a triangle this way, is that each of those were in relation to finding the opposite, the adjacent, and the hypotenuse side of a right triangle. And so now we have this right triangle where theta is the angle here. So the angle here represents theta. I'm going to draw on the little triangle and on this larger one just so you have a better look at what's going on. And then one thing that we talked about was that the hypotenuse is the side across from the right angle. So in this, our hypotenuse is here. One thing to notice is that in the unit circle, the hypotenuse is actually always 1. So no matter what we're doing, the triangle, because of the radius of the circle, has a hypotenuse of 1. So that's going to make things easier for us within each of these problems. So I'm going to highlight that just so you know where it came from. So within the unit circle, we have a circle with a radius of 1 again. So that means the hypotenuse, no matter what, is 1. And so then in relation to theta, the side that's opposite theta is the side over here. So that's this side. And so notice that that side is labeled as y. So the y will always represent the opposite side when I'm looking at a triangle set up in the unit circle. And then finally, the adjacent side is the bottom part here. And notice that that is labeled as x. And so within the unit circle, because the triangles are always centered at the origin, and so if I were to do a triangle in the other quadrant, it would still relate the same way, where this is x, this is y, and this is 1. Same thing if I did it in the bottom half. So we saw that when we flipped triangles yesterday when we built the unit circle. So if I think about sine as opposite over hypotenuse, using what we have here, sine of theta is going to be y, which is the opposite side, over 1, which is the hypotenuse. So what that means is that we can think about sine of theta as just y. So anytime we're using the unit circle and we're asked to find the sine of an angle that's on the unit circle, the answer is just the y value. Similarly, since cosine is adjacent over hypotenuse, that's x over 1, And again, since the hypotenuse is 1, anytime that we're asked to find cosine of the angle, we actually just need the x value as long as that angle is on the unit circle, because again, the hypotenuse is 1. Finally, we know that tangent is opposite over adjacent. So looking at our triangle, the opposite side is y over the adjacent side is x. And so to find tangent of a value on the unit circle, we will use the form y over x. So one thing that's important is that you need to memorize these because you will be quizzed on them. So we will practice with finding trig functions when the angle is inside the unit circle. Okay, so these are going to be on the next quiz where you won't be able to use a calculator, but you will be given the unit circle. So the unit circle is working as your calculator to check that you know that sine is y, cosine is x, and tangent is y divided by x. So example 1 is just asking us to find sine and cosine. And then example 3 is asking us to find tangent. We're doing the same angle measures for each of them. So that part's not going to change. So this is where we're going to go back and refer to the unit circle for each problem. What we're going to take away from the unit circle is simply the ordered pair at that angle measure. So for A, we want to find sine and cosine of 2 pi over 3. So what we're looking at is on the unit circle at 2 pi over 3, we're going to write down the ordered pair. So at 2 pi over 3, the ordered pair is -1/2 and then comma the square root of 3 over 2. Okay, so we're just going to write that down. So -1/2 is the x coordinate. The square root of 3 over 2 is the y coordinate. We know that sine of theta is equal to the y coordinate. So that means that sine of 2 pi over 3 is the square root of 3 over 2. And that's all we have to do. So we're just identifying the point on the unit circle. Its y coordinate is the sine. Its x coordinate is the cosine. So that means that cosine of 2 pi over 3 is -1/2. Okay, so again, we're just looking at on the unit circle and writing down that ordered pair. That ordered pair gives us our answers. So what's going to be difficult, per se, for B is that -45 degrees is not technically on the unit circle. So I can't just look at the unit circle and say, oh, exactly, there's -45 degrees, because these are all positive angles. So what I have to do is find the coterminal. So remember that if I have an angle that is negative, I want to take the -45 degrees and I want to add 360 degrees to see where that ends up. And so -45 plus 360 is going to give us 315 degrees. So that's the value that's on the unit circle. So my coterminal angle to -45 is 315. So now I'm looking at 315 on the unit circle. And so that angle measure is down in quadrant 4. It tells us that the x coordinate is the square root of 2 over 2 and the y coordinate is -square root of 2 over 2. So we're going to use that point to answer the question. So we're going to write down square root of 2 over 2, comma, -square root of 2 over 2. And the y coordinate is our sine value. So that means sine of -45 is -square root of 2 over 2. And the x coordinate is our cosine value. So that means that cosine of -45 degrees is the same as cosine of 315, which is positive square root of 2 over 2. So either the value is strictly exactly on the unit circle, or we need to find a positive or negative coterminal angle. A positive coterminal angle if it is a negative value. So that's way easier for things that are in degrees. So when we have radians, things can be a little bit more complicated. So I'm going to show you kind of two different ways to identify negative 5 pi over 6 looking at the unit circle. So we can either do this visually, knowing that we go backwards to do a negative angle. The other thing that we can do is, instead of adding 360, we can add 2 pi. And finally, we can look at it in degrees instead. So I'm going to give you a couple different ways to approach the problem when I'm given a negative radian. So if I have sine of negative 5 pi over 6, I'm looking for negative 5 pi over 6 on the unit circle. So if I check out where positive 5 pi over 6 is, if I think about this angle, I'm going through quadrant 1, and then I'm going to the third mark in quadrant 2. So that would be positive 5 pi over 6. And then if I think about doing that, but the opposite direction, so I'm essentially finding the reflection of the angle that I just found. So instead of going up from 0, I'm going down. That creates a negative angle. So negative 5 pi over 6 would be actually equivalent to 7 pi over 6. Okay, so visually, that's what I would do to identify where negative 5 pi over 6 is. So I'm checking where is positive 5 pi over 6. Okay, I went a full 90 degrees, and then I went another almost to 180. Okay, so I went another, what is that, 75 degrees. So then, I'm sorry, that's another 60 degrees. And so then we're going to use the reflection of that, which is the point negative root 3 over 2 comma negative 1/2. Okay, so this point is going to be at negative root 3 over 2 comma negative 1/2. Since you have the unit circle, and it's easier to work with degrees than radians because all the radians are in fractions, one thing to think about is if I look at what is negative 5 pi over 6 in degrees, so 5 pi over 6, if we just look at our unit circle, is equal to 150. So if I take 150 degrees, and remember we talked about if I do 360 plus that value, that's going to give me 210 degrees. So that means that negative 150 is equivalent to positive 210. And notice that's where we were, right? So negative 150 is equivalent to that positive 210. They're positive and negative coterminals. So that's another way to get yourselves to the negative square root of 3 over 2 comma negative 1/2 as your ordered pair. The last thing or method that you could use to find that, I'm just going to erase all the markings that I made on this unit circle, is that you could keep it as this, but what you would do is you would have to add 2 pi. And so what makes that more complicated than just looking at what is 5 pi over 6 in degrees is that in order to add these two together, you would have to multiply this guy by 6 over 6 so that they both have a denominator of 6. And so that'll give you 12 pi over 6 minus 5 pi over 6, which is 7 pi over 6. Okay, so you have 3 different methods to get this angle, that ordered pair. You're either visually finding the 5 pi over 6 negative direction. You're either converting that to degrees and adding 360 to negative 150, or you're adding 2 pi to negative 5 pi over 6 because 2 pi is a full revolution in radians. So lots of ways to get to that point, and that point tells us that the sine of negative 5 pi over 6 is negative 1/2, and the cosine of negative 5 pi over 6 is negative root 3 over 2. So those two values are our solutions. Finally, for D, we have 450 degrees. And so what we should notice is that that's larger than the unit circle. So in this case, just like when we have a negative angle, we're finding the coterminal. Since it is a large angle instead of a negative angle, what we're going to do is we're going to take 450 degrees and subtract 360. Okay, so we're not doing 360 minus the angle, we're doing the angle minus 360. And so when we do that, that tells us that this is a 90-degree angle. So we're actually finding sine, cosine, tangent of 90. So if we look at 90 degrees, the ordered pair is 0, 1. So we're going to use that point 0, 1 to find sine and cosine. So sine of 450 is the y coordinate 1, and cosine of 450 is the x coordinate 0. Okay, so what I want you guys to do now is in your student companion on page 150, or on the separate piece of paper if you haven't been having your student companion with you, I want you to try try it number 1, part A and B. So they're both in radians. You're just finding the sine and cosine of each of those two angles. So if you can pause the video and then write the answers down or check the answers with students once they've gotten that solution, and then we'll resume the video once everyone has finished that problem and they've gone over the answer. I'll display the answer in a second. Okay, so the x coordinate for 4 pi over 3 was -1/2, so that's our cosine value. The y coordinate at 4 pi over 3 was -3 over 2, and so that's our sine value. Similarly, the coordinate for 3 pi over 4 was -radical 2 over 2, comma, radical 2 over 2. So the -1 is our cosine, and the +1 is our sine. So now what we're going to do is look at tangent. So ultimately, these angle measures are the same. So the points that we're talking about are the same points that we did in example 1. But what's going to change is that instead of just picking y, just picking x, to find tangent, we actually have to simplify and our answers. So when we have 2 pi over 3, remember that the ordered pair at 2 pi over 3 is -1/2, comma, root 3 over 2. Okay, so the equation for tangent is y over x. So that means that we're going to take radical 3 over 2, which is our y value, and we're going to put that over our x value, which is -1/2. And so we don't just leave our answers like this. We don't use complex fractions as a solution. What we have to do is simplify. And so remember that if I have a fraction over a fraction, I take my numerator, which is radical 3 over 2, and I multiply it by the reciprocal of my denominator. So instead of doing -1 over 2, I'm going to do 2 over -1 to create and simplify my answer. So notice that I have a 2 in the numerator and a 2 in the denominator, so those can reduce. So technically what I have here is the square root of 3 over -1. And so simplified, that is just negative square root of 3. So tangent of 2 pi over 3 is negative radical 3. So again, when I'm doing this on my homework and I'm on a quiz, you need to show your work, your steps for dividing. So I need to see y over x, and then whatever you do to simplify, and then your final answer. So for tangent of -45, we found that the coordinates at -45 are positive radical 2 over 2, comma, negative radical 2 over 2. And so tangent, again, is y divided by x. So that's going to be our negative radical 2 over 2 over the positive radical 2 over 2. And this one's actually pretty nice because radical 2 over 2 and radical 2 over 2 are the same. So if I have something divided by itself, those are going to turn into 1. So negative radical 2 and positive radical 2 each cancel. If I reduce this, I get negative 1 over positive 1. So the tangent of negative 45 degrees is negative 1. Okay, so when I have the ones that end in 5s for degrees and the ones that are over 4 in radian, this will always happen when I find my tangent because the x and y coordinates are the same aside from maybe a positive or negative. So tangent of anything ending in a 5 in degrees or over a 4 in radians is always going to be 1 or negative 1. Then we have our negative 5 pi over 6. So remember that we found that the ordered pair at that terminal point is negative radical 3 over 2, and then negative 1/2 is the y coordinate. And so that means that tangent is going to be negative 1/2, our y coordinate, over negative root 3 over 2, which is our x coordinate. So since both of these are negative, I can reduce this and I know it's going to be positive. So when I simplify this, I've got my 1/2 times the reciprocal of the denominator. So times my 2 over radical 3. And again, since they're both negative here, I know that this is going to be a positive value. So when I simplify this, the 2's reduce, but I'm still left with 1 over the square root of 3. So remember that we do have to rationalize any denominators. Which means that I'm multiplying this by radical 3 over radical 3, so that I get the square root of 3 over 3 as my final answer. So tangent of negative 5 pi over 6 is the square root of 3 over 3. Finally, we had 450 degrees, which we found its coterminal angle to be 90. And so that meant that we had the point 0, 1 as our ordered pair. So since tangent is the y coordinate, which is 1, divided by the x coordinate, which is 0, that means that our answer is actually going to be undefined. So I cannot divide anything by 0. So for tangent of 450, we have an undefined value. Kind of hint to this is it's okay to divide by 0. It is not, sorry, it's okay to divide 0 by something. It is not okay to divide by 0. So it's okay? No. So we are not allowed to have the 0 in the denominator. We are allowed to have the 0 in the numerator. So finally for this, you're going to do the problems on page 320 and 321, I believe. However, I want you to find the sine, cosine, and tangent of each of them. Some of them say find the sine and cosine, others say find tangent in your textbook. But I do want you to find all 3 for each of the homework problems. So remember that when we're looking at sine and cosine, it's literally just the x coordinate and the y coordinate for the appropriate function on the unit circle. Then to find tangent, we're dividing the y coordinate by the x coordinate, and you always simplify. So if you on a quiz just tell me that tangent of 2 pi over 3 is radical 3 over 2 over negative 1/2, you will miss that question. So make sure that you are simplifying and not just writing it as a complex fraction. So that's never an okay answer. So before we start on the homework, what I want you guys to do is to find the tangent of each angle on page 151 in your student companion. And again, if you can pause the video until everyone's kind of stopped, and I'll give you the answers at the end, but you can walk around and check based on what I've left in the notes. Okay, so the answers for the try 3A is undefined. So that coterminal angle is 90 degrees, negative 3 pi over 2, or positive pi over 2. And then the coterminal angle to 675 is 315. So using the unit circle, tangent of 675 then is negative 1. So again, the homework problems are these angle measures. So you're finding the sine, cosine, and tangent of each angle. I've taken the time to write those on the board as well. So if you want to just pull up the screen and turn off the video, this is all written on the board to copy. So make sure you have your unit circles out.